This project involves an ultra-large coke oven gas holder within the plant area, which is one of the important production facilities of the plant. The gas holder covers an area of 1,500 square meters, has a height of 81 meters, and is a regular icosagon in shape, with a maximum gas storage capacity of 120,000 cubic meters. The foundation of the gas holder consists of a ring beam plus a pile foundation with mechanically bored cast-in-place piles. The pile diameter is 800 millimeters, and the design pile length ranges from 26 to 33 meters. The gas holder was put into operation at the end of 2022, and soon after reaching full capacity, it experienced uneven settlement, with the maximum settlement reaching 112 millimeters, which continues to progress. The gas holder as the whole tilts towards the south, with the top of the structure shifting southwards by approximately 190 millimeters, resulting in the gas holder being unable to function normally. Upon being commissioned by the client, Hengxiang Hongye conducted an on-site investigation and analysis. The primary reasons for the settlement were identified as follows. 1. The pile tips did not reach the bearing layer, or the depth into the bearing layer was insufficient, resulting in uneven settlement. The foundation soil consists of a man-made fill with a thickness of about 30 meters. The soil layer structure is loose with a high porosity rate. The foundation soil experiences significant differential settlement upon compression due to poor uniformity of the foundation. Additionally, the presence of the large gravel, despite dynamic compaction treatment, still leads to weak soil layer areas locally, which is a major cause of the uneven settlement. 2. During the rainy season and periods of abundant water, there may be standing water in the upper layer locally, causing uneven settlement of the foundation. Therefore, to solve the settlement issue, it is necessary to solidify the backfill soil layer as a whole, forming a high-strength slurry soil composite to enhance the bearing capacity of the foundation and achieve permanent stabilization. The construction is carried out in 3 steps. The first step: reinforcement of the pile end and surrounding foundation. This mainly involves the reinforcement of the soil around the pile, particularly in the 5 to 8 meters range above the pile end. The purpose is to protect the pile foundation to prevent displacement during the lifting process. At the same time, it aims to expand the stress area at the pile end, increase the grip force of the soil around the pile, and form a stress layer, making the lifting force more uniform. In this stage, the hole positions are uniformly arranged according to the structure and foundation form of the gas holder, with a spacing of 4 meters. The second step: retraction lifting into the bearing layer at the pile end. After the reinforcement of the soil around and at the end of the pile is completed, drilling continues downwards for 3 to 5 meters below the pile end into the bearing layer to implement layered retraction lifting. Driven by pressure, the grout enters the foundation to form grout bubbles and spreads around. As the consolidation of the grout and soil progresses, the volume of the grout soil composite gradually increases, and the internal pressure of the grout rises. At this stage, the vertical force begins to manifest, and the lifting effect becomes gradually significant. Since the lower soil layer is dense, the soil does not settle. With the continuous injection of grout, an upward lifting force is formed under pressure. In this stage, lifting is carried out in cycles from areas with larger settlement to areas with smaller settlement, with each cycle of lifting height controlled between 3 to 10 millimeters. Due to the compaction of the soil layer, the structure slowly lifts. The maximum lifting per hour does not exceed 2 millimeters, and the maximum lifting per day does not exceed 10 millimeters. This allows for precise control and flexible lifting, while ensuring the structure remains undamaged. The third step: overall reinforcement and filling around the pile. After the gas holder has been lifted and rectified, Comprehensive reinforcement treatment is applied to the soil around the upper part of the pile to increase the lateral friction resistance of the soil surrounding the pile. The complete bounding of the slurry with the soil around the pile plays a protective role for the pile foundation, ensuring that both the pile foundation and the base achieve permanent stability. These three steps ensure an overall reinforcement depth of 32 meters below the foundation, guaranteeing penetration through the backfill soil layer. The reinforcement and lifting of the foundation are continuous and uninterrupted processes. When fluctuations appear at monitoring points, it indicates that the foundation has been densely filled, and the vertical forces begin to manifest. At this point, appropriately adjusting the pressure, slurry mix ratio, and slurry injection rate is necessary to ensure the gas holder is lifted evenly and gradually. When the lifting height approaches the target height, adjust the relevant parameters again for fine-tuning to ultimately meet the verticality requirements. We utilize special new composite materials, employing a minimally invasive technique with small bore holes of 10 millimeters. The slurry can solidify within 1 to 30 seconds. By controlling the material's solidification time, we are able to adjust its diffusion range and rate, thus achieving the flexible lifting of the gas holder. During the lifting process, the gas holder structure remains undamaged, and the equipment can continue to operate normally. At the same time, we employ precise monitoring equipment for real-time dynamic monitoring, achieving millimeter-level accuracy control, ensuring the precision of the lifting process is accurate and controllable. After 25 days of professional treatment, the cumulative maximum lifting reached approximately 110 millimeters, and the inclination of the gas holder was controlled within 0.3 per mil, meeting operational requirements while also satisfying the design standards for foundation bearing capacity and inclination.